Hi friends, I am N. Chandrasekharan, Assistant Professor, Department of Chemistry, Sri Vidya Mandir Arts and Science College, Uthangarai, Krishnagiri District, Tamil Nadu. In this video, I am going to explain some basic concepts in optical isomerism. We will see one by one. The first topic is racemization. Racemization is the process of converting an optically active form into an optically inactive racemic mixture. The plus form is optically active. The minus form is optically active. This plus form or minus form is converted into an optically inactive plus minus form, which is called as racemic mixture. The plus minus form is called as racemic mixture. Racemic mixture is the mixture of 50% plus form and 50% minus form, which is optically inactive because of external compensation. So the conversion of this plus form or minus form into plus minus form is called as racemization. Both plus form and a minus form optically active. This plus form or minus form is converted into the plus minus form is called as racemization. So the conversion of an optically active plus form or minus form into an optically inactive racemic mixture is called as racemization. There are various methods employed for racemization. Only few methods I am going to explain. Number one, action of heat. Number two, action with the chemicals. Number three, auto-racemization. There are three methods employed for racemization process. The first method is action of heat. In this method, the optically active plus form are heated at particular temperature. We get racemic mixture. That means by heating D form and L form at a particular temperature, we get racemic mixture. Example, you take lactic acid or tartaric acid, either lactic acid or tartaric acid, D form lactic acid and L form lactic acid. Both D and L form of either lactic acid or tartaric acid are heated at a particular temperature. We get racemic mixture. Number two, action with chemicals. In this process, the racemic mixture is obtained from an optically active plus form or minus form by using some chemicals. Example, when metallic acid is treated with HBr, we get plus minus bromometallic acid, which is an optically inactive racemic mixture. Whereas the mandelic acid is optically inactive, that mandelic acid is treated with HBr, we get plus minus bromomandelic acid. So is one of the methods for racemization. The third one is auto-racemization. In this process, the racemization takes place automatically. Racemization takes place. Example, lactic acid, tartaric acid. Right. Next topic, resolution. The resolution process is reverse that of racemization process. In racemization process, the plus form or minus form is converted into plus minus form. Whereas in resolution process, the plus minus form, which is optically inactive form, is converted into either plus form or minus form. So now an optically inactive racemic mixture, that is plus minus form, is converted into an optically active either plus form or minus form, is called as resolution. This resolution process involves various methods. There are various methods involved for resolution process. Only few methods is included here. Number one, the most important method for resolution is biochemical separation. In this biochemical separation, the optically inactive form is converted into an optically active form by using some microorganism. When the microorganism is allowed to grow in a solution of racemic mixture, during this process, one isomer being destroyed, another isomer being separated. For example, you take a plus minus tartaric acid solution in a beaker. In this beaker, the microorganism Penicillium glacium, that Penicillium glacium is allowed to grow in a solution of plus minus tartaric acid. That Penicillium glacium destroy plus tartaric acid and minus tartaric acid being separated. So in a beaker contain plus minus tartaric acid, which is racemic mixture. Our aim is to convert the plus minus tartaric acid into either plus tartaric acid or minus tartaric acid. So for this process, we are using microorganism Penicillium. So the Penicillium glacium destroy one isomer, one isomer, that means plus tartaric acid, and another isomer minus tartaric acid being separated. So the biochemical separation involves the conversion of the optically inactive plus minus form into an optically active either plus form or minus form by using microorganism. So if the conversion using microorganism, then the separation process is called as biochemical separation. Number two is selective adsorption. In this process, we are using an adsorbent. That adsorbent adsorb one isomer. The racemic mixture contains two isomers, plus form and minus form. Both are present in equal amount. If you add adsorbent, that adsorbent selectively adsorb one isomer, so that we can separate another isomer. So in this process, we are using an adsorbent. Camphor is one of the adsorbent. That adsorbent adsorb D-tartaric acid in a DL mixture and L-tartaric acid being separated. Third method is resolution salt formation method. In this salt formation method, the optically inactive racemic mixture is converted into an optically active either plus form or minus form by salt formation. So the third method, the salt formation method, involves the plus minus form in the form of acid or base. That means plus minus acid or base is treated with an optically active acid or base. We get optically active salt, optically active in the form of salt. So there are three methods involved for resolution: biochemical separation, number two selective adsorption, number three salt formation. Thank you.